Hello, welcome to the September 2017 Get Started with CyVerse webinar. I am Jason Williams, coming to you from Cold Spring Harbor Laboratory, New York. Welcome. This is a monthly webinar that we use to invite all of the new registrations that have occurred over the last 30 days or so to come find out directly a little bit more about CyVerse and what comes with your CyVerse account, what you can do with your CyVerse account. So over the next almost an hour or so, we are here to answer your questions, and of course I'm going to take you through several live demos as well as a little bit of the background of the CyVerse project. Before we get started, let me take the opportunity to familiarize you with this Adobe Connect technology that we're using for the webinar. Importantly, the reason when we do this live is that we can take your questions. So at the bottom of the screen, there is a place where you can at any time answer or ask your questions. And off screen here, I can see any questions that are asked of me. So take advantage of that. That's one of the reasons why we do this live. Additionally, on the bottom of the screen, on the side of the screen, you'll be able to see that there are some downloads for you. So if you click on any of those links on the bottom, those are links to some of the learning materials that you can use. People may choose to follow along, but most likely you might think about coming to those later. There are also a couple of downloads on the side of the screen that you can use as well. Finally, at the top of the screen, there's a little button with 4 arrows in it, and you can actually make the video full screen. And that'll be useful during the parts of the demo when I am sharing my computer screen. Things may be a little bit smaller, so watching the video full screen will help you there. If at any time you have any type of connection issue, moving your mouse over the screen, you can actually adjust the bandwidth, whether it's HD or a lower resolution, or if you have any other types of issues, you can either talk to us at the bottom, but sometimes in the rare case where you do have a technical issue, usually leaving the room and restarting it will just be enough. Okay, so first what I want to do is give you a little bit of background about the CyVerse project, and then I'll move on to 3 live demos where I'll walk you through some of the basic steps for uploading your data, doing an analysis, and even seeing how you can work in the cloud. So some things to get you started. So let's begin. So the project as a theme has this motto, transforming science through data-driven discovery. So over the past several years, we've become a project, and really even a community, with more than 40,000 users, petabytes of data, and hundreds of publications, courses, and discoveries that are enabled by the CyVerse cyber infrastructure. Now originally, some may or may not be aware, we started with a different name, which was the iPlant Collaborative. This was a cyber infrastructure project funded by NSF, and with the goal of empowering new plant biology. That was back in 2008. As the project proceeded with feedback gathering from the communities, we launched, and then we were successfully renewed in 2013. The project took on a little bit of a broader mission of providing cyber infrastructure for life sciences, and as we continued to become broad, part of that was the changing of the name to CyVerse to be more representative of the fact that we really incorporate the entire life science community and want to transform science by data-driven approaches. So one of the first things I want to mention right off the bat is that we are funded by the National Science Foundation. So we're your colleagues and your collaborators. This is a $100 million investment that NSF has made in resources, and our goal is to help use those resources to make you better at the research that you do, enabling your science. The entire research platform is open. You don't have any direct cost for using that, and we're even open up to international collaborators, and we have users across the globe. So that being said, we really do ask that our users think about citing us and acknowledging us and the contribution that we and also NSF has made. The other thing that's exciting about that is really it's an investment that's there, and these are resources that are open for you to have. So it's $100 million of work that's on the table, and the part of this webinar and our whole goal is to help you identify the pieces of that that are compatible with your research and going to move you to the next step moving forward. Okay, so I've used the term cyber infrastructure several times, so let me just briefly explain that. Cyber infrastructure, in one sense, is not anything you aren't already familiar with. It's data storage, software, high performance computing, and even people. But it's the organizing of those things into systems that help you solve problems of size and scope that wouldn't otherwise be solvable. So in other words, taking these things and really customizing them for what is the sort of modern 21st century life scientist. This community-focused cyber infrastructure, practical examples are the platforms, tools, and data sets you'll have access to, as well as you have access directly to storage and compute, and this webinar is an example of the third branch of that, the training and support. Another key take-home message is that CyVerse is built for data. So no matter what type of organism you're working with, or even the different types of data sets you may be working with, CyVerse is built for all of these, and so you'll find tools and resources to help you manage every part of the sort of workflow and the life cycle of your data. This is a somewhat broad overview of what we call the CyVerse product stack. So as a life scientist and perhaps even as a bench scientist, you may only be aware or interact mostly with things on the surface, these products. Things like our cloud computing and atmosphere or web-based discovery environment if you're teaching in the classroom, subway, or working with images. But beneath, there are a whole layer of other services, assets, and resources. If you are a developer by bioinformatician, these are things that you also have access to CyVerse. So really have a pretty open platform. In fact, it's all open source. For most of us as bench biologists, we'll be operating at this layer, but if you are a developer or a bioinformatician, you really have access and a way to customize your use of the entire product stack, which serves the product. Now, as a scientist, you may also be interested in what are the priorities, and these are all set by the community. So whether you're doing working with genomic data, which happens to be really the big driver, you'll find the tools and resources for all of these things. So everything from reference-guided assembly to variant calling, RNA-seq, ChIP-seq, all of these are the bread and butter of what many people are working with today, and you'll find that you're able to do those effectively within CyVerse. It's also important to acknowledge the different institutions that make up CyVerse. Primarily, our staff is located at the University of Arizona. We also have a great deal of computational resources also through Texas Advanced Computing Center, UT Austin. I'm at Cold Spring Harbor Laboratory in New York, and here we drive the science priorities as well as education and outreach, and we also have collaborators at UNC Wilmington. And there is a separate project, the CyVerse UK, which is separately funded by BBSRC, that is a collaborative organization of several institutions and universities in the UK. Okay, so that was a little bit of a background of the project. As we saw from the poll, most of our users hear about us from word of mouth, so this is our chance just to give you a little bit of an idea of the context of the project. What I want to move into are practically what are the things that you got with your CyVerse account on day one, how can you use those, and then we'll go into the demos. So I use a metaphor here that we like to use, thinking about CyVerse as Lego blocks. We've built 95% of the things that you want, but often it's about putting those pieces together to build the end solution. So really, these are the foundational pieces that you as a user want to be familiar with so that you can navigate CyVerse and build towards the outcome that you need for your research. Okay, the first thing is the data store. So the data store is the place where you can go ahead and deposit all of the research data, whatever type of files you're working with. Every user has an initial 100 gigabyte allocation. If you need up to 10 terabytes, you can have that as well, but we do need a little bit of justification. And if you have a very special project and you need more, we can also discuss that. This is all free, of course, but we want you to use it responsibly. Additionally, we've engineered the system so that it's automatically backed up, and we've made it fairly easy to upload, download, and share, and I'll be showing that in our first demo. We also have the discovery environment. So many biologists, bench biologists in particular, would like to be able to operate in a graphical environment where they can point and click their way through an analysis. And so the discovery environment is a platform that can run almost any bioinformatics application that you'd run at the command line. It's integrated with our data and high performance computing resources, and it's also user extensible, so you can add your own applications. Atmosphere is the cloud computing platform. If you've not used cloud computing in the research context, our final demo will show you why it's very compelling to actually learn about the cloud and see how you can access the cloud, and it's integrated again with our computing and data resources. There are a couple other pieces that I will not be directly demoing. They either underlie the technology, such as the science APIs, or there's something that we can't simply cover in this amount of time. But the science APIs are our Science as a Service platform. So it allows you to define your own compute and storage resources, both local and CyVerse. You may have a cluster, you may have resources, and you can sort of mix and match those with CyVerse. It also allows you to build your own app store, so to speak, of scientific codes and workflows. DNA Subway is really a wonderful tool if you're working in the classroom and you want to bring bioinformatics in as part of your teaching, which of course I think most of us want to. It is several commonly used bioinformatics tools in streamlined workflows, helps you to teach important concepts in biology and bioinformatics, and it is supported by several inquiry-based experiments where you can really do novel course-based research experiments. BISC is our platform for working with image management, metadata. It supports more than 300 image formats, and again, it will allow you to work with thousands, tens of thousands, millions of images that might be associated with phenotyping or other digital collections that are visual. Okay, so that was some of the bigger Lego blocks, if you will. Now what I'm going to move into is a series of a few short demos. If you're just joining us, if some didn't join at the beginning, at the bottom of the screen there are a couple of links, and in particular is the CyVerse Learning Center, where most of what I'm going to present is being drawn for. This entire video presentation will be recorded and posted onto YouTube, so if there's something you missed, you always have the opportunity to come back. I'll also remind you at the bottom of the screen at any time, off screen, I can see any questions that you'd like to share, so please at any time just stop me with any questions you might have. But if you're just watching, sit back, relax, and sort of get an idea of the various steps that are involved. The first one that we're going to cover is getting your data into CyVerse. Okay, so just to recap, as I said before, when it comes to moving data into the CyVerse data store, you can store any type of file that's related to your research. I'm going to show you how you can move those files between different CyVerse platforms or access them in different platforms. You can automate your file transfers if you so choose, and you can share files with lab members, with your colleagues, and with the community. There are a couple of important ways to access the CyVerse data store. So the ones I'll show, in fact I'll show all three. The easiest one is one that we call CyberDuck, which is a standalone tool that we don't produce but that we use. We also will show you the discovery environment, which is excellent for sharing, as well as at the command line so that you can automate. There are different advantages to each one of these platforms. In the discovery environment, since this is a web-based platform on a standard HTTP protocol, there are some limitations, and so we recommend that for smaller files, but you can also import from URLs. It's great, by the way, as I'll show, for sharing. CyberDuck is the tool I'll show first. It works and turns your computer into something like Dropbox, where you can easily drag and drop files and folders. There's no size limit. And on a good connection, you'd expect to move something like 100 gigabytes in around 30 minutes. iCommands gives you full flexibility. It is at the command line, which some people may not have much experience with, but if you do, or you're willing to take a few moments to learn, you can script and automate your transfers, and it's wonderful for connecting your various servers to the CyVerse data store and moving data that way. Okay, so in this demo, I'm going to show you a few of those methods. Again, everything is documented in the Learning Center. The video will be recorded, so hopefully this gives you an idea of where to start. First, let me just take the time to bring up the CyVerse homepage. This is where a lot of the materials are. We do have a CyVerse Learning here, but we're moving slowly but surely to a new CyVerse Learning Center, and this is the link that's provided to you in the webinar. So all of that documentation for this particular demo that I'm going to show is in the data store guide. So you might want to think about going into learning.cyverse.org, and from the data store guide, essentially I'm going to walk you through these various steps, but it's all here for you to follow along at your own pace when you so choose. So let's start with CyberDuck. The very first thing that you have to do with CyberDuck, and I can pull this from the Learning Center, is you need to download CyberDuck and you need to download a configuration profile. CyberDuck is a third-party software, so you'd have to be able to go to the CyberDuck website and just go ahead and download that. It'll just take a moment to download CyberDuck. And then you do a second download of a small file which helps you configure CyberDuck for the CyVerse data store. Now I already have CyberDuck running on my computer. This is the application. In fact, if I start it just from the beginning, and CyberDuck is available for Windows and as well as for Mac. Actually, I have to do it this way. New browser. When you properly configure it, and it takes, I would say, just 2 or 3 minutes, what you will get is a bookmark to the CyVerse data store, and then you double click on that to connect. Once you're connected, it looks like it does in my window here. All of these files or folders are items that are located and saved on my CyVerse data store. If I want to move those files or folders, then it's just a matter of clicking an individual file or folder and dragging it to the location I want. In this case, I may drag it to the desktop. A dialog will open and this transfer window, and then I can monitor the progress of any particular transfer as it moves from my CyVerse data store on the left-hand side to, on the right-hand side, my download. I'm doing this over wireless. The first few seconds is just protocols exchange, and then the download would go ahead and proceed. But that's really all it takes in order to move a file. If I go ahead and create a file on my desktop, this is an empty file, it has nothing in it. But again, it's the same process. I could take this file, or it could be a folder, and move it onto my CyVerse data store. I could choose where, in another folder or in my home directory, and the same thing would happen. In the transfer window, it would go ahead and initiate that transfer after a few seconds. Okay? So you get an idea, these are both done, that you can move and match, files just by dragging and dropping them. And there's really not that much more to show you about getting started with CyberDuck. There are a couple other features for moving around the entire CyVerse data store, but that is the main point. It is a simple, easy to use drag and drop interface. The next one that I'll show you is the command line interface. So let me close this for the time being. And if you are in the CyVerse Learning Center, there is a link on working with something called iCommands. So iCommands is also by a third-party developer by the NSF-funded iRods project. And through iCommands, which we use iCommands and iRods, is the actual technology that underlies our CyVerse data store, you can script and automate. There is a download step, and you download the iCommands either for Linux or for Mac. There is no version currently for Windows, although it may be the case that the Windows with Bash kernel may work. I haven't tested that yet. You have a one-time configuration, and then it's installed on your computer. Now in my case, I've already installed it, so let me just open up a shell and let me just choose a color a little bit easier to see. So this is my terminal on my Mac, and if I want to view the contents of my CyVerse data store, instead of an ls, which is a Linux command, I use ILS, and then I can view the contents of my CyVerse data store. All of the commands are of course documented, and you'd find that in the Learning Center. So for example, if I wanted to download a file, let's go ahead and get a folder this time. I can from here do the iget command -r progress verbose and do a socket reset on the VCFs folder, and I could move that to my desktop, and I hit enter, and that would go ahead and start the download. My folder appears on the desktop, and I get a progress report as the download continues. It's finished now, and then I have this VCF folder along with whatever files happen to be in that VCF folder. Okay, so using iCommands, of course, there's a whole bunch of other functionalities, but the iget and the iput are the upload and download commands, and There are several other functionalities, but that is, again, the bulk of what you may want to do, with everything else being documented quite thoroughly, both on a CyVerse Learning Center as well as the documentation homepage for the iCommands. Now, the next thing we're going to talk about is sharing and working with your data that way. From the CyVerse homepage, if you do go to the CyVerse homepage, we're going to do this and manage the sharing in the CyVerse Discovery environment. So I'm going to go ahead and click on the Discovery environment. And at the bottom, there's a link to go ahead and launch the DE. And from there, I'll go ahead and log in with my CyVerse credentials. Okay, and now I am logged in. It's going to open to whatever is the last thing I was working on, which I don't remember at the moment. Maybe I closed all my windows. No, I had a couple open. So this is the CyVerse Discovery environment. We'll talk a little bit more about this as a platform for analyzing data in just a moment. But for right now, I'm just going to focus on one feature, and then we'll come back to some additional ones. So if I click on Data and click on my Home folder, once again, I'm viewing the contents of my CyVerse data store that I've now seen previously in CyberDuck and also on the command line, but these are the same contents. So there are some basic data features here for uploads and downloads. If I want to upload, I can upload from my desktop a few small files. If I want to import from a URL, I can paste in the URL. This again is slow, so if you have alternatives, especially for a large file, you might want to do that. The other features that are here include downloads, if I select a file or folder. But what I want to focus on here is sharing data. So there's a couple of ways to share. One of the easiest, and this works for sharing an individual file, is to go ahead and select the file and then go up to Share and click Share, Create a Public Link. When I confirm that that's the file that I'd like to share, as I could see, I'm already sharing this with some folks. So I would go ahead and I can create a new URL by clicking the Create button. Then I can take that URL and say Show Link. If I give that URL to anyone else and they paste into a browser, they will get a dialog to go ahead and download that file. Now this one happens to be quite big, 1.3 gigabytes. So I probably wouldn't want to share something that big over the internet. Over HTTP, it could be a bit slow or unreliable. But you get the idea that you can go ahead and share files that way. If I wanted to no longer share a file that way, I could come back and just click on the delete link, and that URL would then be discarded. Anybody who came back to try that URL again would find that they could no longer download. So this is a really quick and simple way. It doesn't cover all ways to share data, but sometimes you may just have a file or resource you want to make available pretty quickly. When it comes to making available files and resources, we would, in many cases, recommend the CyVerse Data Commons, which is more appropriate for sharing data, especially curated data, and perhaps you want a DOI or other digital identifier on those data sets. But if you're just sharing a PowerPoint or a small file that somebody needs, the public links are a pretty convenient way to do so. I have to warn again that they only work for individual files. So if you had a folder, it would have to be compressed. But let's say you do want to share a rather large data set, maybe files and folders. Well, then what you would have to do is, let's, in this case, assume that we're going to share a folder. Then we can click and highlight that folder and then go back up to Share. In this case, we're going to click Share with Collaborators. So this does require that the person or persons you're sharing with do have a CyVerse account. As you experienced, it's probably not onerous to get a CyVerse account, but the advantage is that the sharing is instantaneous. So what I would do is then search for the user. I'll type in the name of a colleague here. And as you type in the name, you'll come up with that colleague's name and their affiliation. And then you can decide what level of permission you'd like to assign. Let me come back here to the actual documentation and bring up this chart. So when you are sharing, you have these permissions, which are based on Linux permissions. Read permission is the most restrictive, and that just allows the person to read and perhaps analyze those data, view the metadata. Write allows them to alter those data, including the metadata. And own is the highest level of permission, and they can do everything including move, rename, or delete the data, so you have to be careful not to share it at that level unless you're absolutely certain that's what you want. If I was going to share this in reality, I would click Done, but since I always use Cornell as my example, he would always be inundated with this. But after you click Done, what would happen is you get a notification that the sharing has begun, and you would have a fact somebody shared something with me just now. You'd have a link to that, and that person would be able to click on a particular that notification, and in my case, since somebody's just shared something with me, it will navigate to the location of the folders that they have shared with you. The same thing is true if I go to share and I want to revoke permission. Again, imagine that this was something that I had shared with somebody already. I would just come back and open the menu. I could either adjust their permission, or if I wanted to revoke it, I would click the X and click Done. You get another notification that that folder has been unshared, and they would no longer have access. Of course, if they've already moved it or copied it, that's different, but I think you get the idea, the understanding. So that's all that I'd like to show or talk about in terms of sharing. I probably have one more thing that I have just time to show you, which is a little bit about search capabilities, but certainly I think that that's enough to get you started. The idea that you can upload with CyberDoc or the I commands, and then once you have that data up into the CyVerse data store, then you can use one of a variety of tools, including what I'm going to show you next, to analyze this data. Let me show you one more thing about searching for data, a little bit about metadata. Unfortunately, I don't have time to go through it in full detail, but it's another important part of a reproducible science workflow. So let me show you that and then proceed into the discovery environment. So one other feature of the discovery environment here is that you can actually adjust the metadata on a file. If I select a particular file or folder and I go up to metadata, I can edit or view the metadata for that folder. Now this one doesn't happen to have anything attached to it. I can arbitrarily add metadata. I could say something like experiment, experiment title, test, and unit has no unit. And you can sort of save these individual things. Now if I go to, I'm going to not save this one. If I go to something that I know has a fair bit of metadata attached to it, give me a second. Okay, here is a submission to the SRA. And if I go view the metadata for this one, I can see a variety of metadata attached to it. Now this is extremely important because essentially we can't name our files with just underscore this, underscore that, underscore that. Our files contain lots of metadata associated to them, and we can either use our arbitrary metadata, or we can design our own templates, or we can use any of these templates that are provided. The advantage of that is that when you go now to search your data, you can search by any attribute or value. So it's really pretty powerful. So take a look at the documentation for metadata. It's really part and parcel of reproducible science. Okay, so I have a couple slides that are going to take us through the next step, which is orienting ourselves to the discovery environment. So to recap, the discovery environment is a platform, and you can run almost any type of bioinformatics application that you'd normally run at the command line. It's integrated with our data and high performance computing. We've just seen the data part of that. And it's also extensible. Although we won't have a chance to do so today, you can add your own applications, and as you find applications that you'd like to see in there, you can let us know, and you can either put them in yourself or you can ask us for help. We've covered the data window pretty effectively, and that's where you have upload, download of files and folders, share files via URL, public links, or with other users. Now we'll talk about applications where you can run hundreds of bioinformatics apps, build your automated workflows, or modify apps, and also analyses where you have the ability to monitor a job status or history, and also to cancel or relaunch jobs. So in this demo, I am going to take some unaligned DNA sequences in FASTA format and just create a multiple sequence alignment. So it's a fairly straightforward one application process, and it's just enough to get you an idea of how applications run in the discovery environment. Okay, so back to the discovery environment itself. As you've seen, we've got these particular panels. Some other features are notifications of things that's going on. You also have some preferences. In your preferences, you can set, for example, whether you want to be emailed when a job is done, or where you want defaults of analyses to be output to. We've also recently brought intercom to the discovery environment, which is this button on here. So if you have a question or a problem, you can actually get live chat help. It's not 24 hours, but if someone is unavailable to take your message, you can actually get a response back relatively soon. They'll contact you via email. So back in data, let me talk about some test data that we have. Let's see if I want to, where I want to find this data. I have to remember for myself. Okay, it's in community data. CyVerse training. And through here, if I remember, if I put this in the right place, yes, there is some sample data there. So these are just some unaligned sequence files. And if you actually click on a file, in many cases you can view it directly if it's plain text or tab delimited, and it will give you a preview or a visualization of that file. So these are some unaligned sequence files. I'm going to go ahead and use an application to just generate a multiple sequence alignment. So to do that, I'll go ahead into Applications, and this is the catalog of applications that are installed. When I first come into the catalog, I see applications that I've either built or modified myself. And I can search for applications by clicking topic and seeing a grouping by topic or by operation. What I'm going to do now is just search for an application, and I'm going to search for muscle. And when I come back with that application, I'm going to happen to use this one called Muscle 3.8.31. I can see some ratings for this application. Some applications may be rated, but it's just a community curation. If I click on the info, if I don't know what the application does, I can get a short description, a link to a user manual. I can see how many times this application has been run. So I get a citation as well. If I want to leave a comment about this application, I can go ahead and leave a comment if it's working well or if I'm having an issue with it. And if it's a favorite, I can also give it a badge so that I can find it more easily in my favorites. But to actually use the application, I just need to click on the application name. I'll close the app catalog, and then we can start running the application. So first I'm going to give it some comments. This is I can choose where the output is, and I'm just going to leave that by default in my analyses folder. Next, I need to select an input data, so I'm going to go ahead and click on Browse. It's going to navigate to the last place that I was. So I'm going to go ahead, or last place I opened something with, so I'm going to go ahead and find my data set again. Okay, so it's going to be this one. And as we saw, I've got one more thing in this sort of recording menu. Lets me go back and forth between the different things I need to fill out. These are both required, so I have to do them. This happens to be a DNA sequence. Okay, when I'm done, I'll go ahead and press Launch Analysis. I'll get a notification that the analysis has been launched. And then I can click on Analyses. And Analyses is a history of all of the applications as well as the status. So currently I have Muscle 3.8.3 run, and the status is running. And then as I want to check other additional jobs, I can go back and see what the status of those jobs are. So let's say I go back, well actually let's click on the one that I've run now. If I needed to cancel it, I could cancel it from here in the Analyses menu. But if I want to, for example, view the parameters, I can see everything associated with the running of this job. So the first thing is a link to the actual file that this was used as input. That's important. Sometimes you have multiple input files with names that may not make a lot of sense, but you can click on any one of those and you'd be navigated to that file. And I see all the parameters that were used in this analysis. Now, Muscle doesn't happen to have all that many things running, but if I go back to a job that has a lot more parameters, so let's find a top hat job. Let's go back through quite a bit. or I could have actually just searched for it, but since I've scrolled this far already, I could go ahead and say view parameters, and I'd see all of the parameters that I've set. This can be saved as a simple text file by clicking Save As, but you get the idea that you have a history. Now I'm going to hit refresh because I saw that this has completed. Before I actually go ahead and view the results, I also want to point out that for any application, if I click on that application and go up to Analyses and click Relaunch, the application will relaunch, and instead of me filling in the blanks with whatever type of files or data I used previously, all of those things will be pre-selected as to whatever I used previously. This one didn't have all that many inputs, but if I maybe this time search for, well, here's a top hat job, and I click relaunch, suppose that I had to, really work with some data and I only wanted to change one parameter. I've changed lots of others. I wouldn't have to go and click my way through 20 different things just to redo that job. It would relaunch with the parameters I used originally. But going back here and refreshing, I see that this is completed. So if I click on the name of the job, it's going to go ahead and take me to the actual output of that job. So again, I don't have to guess it, but where that output is. And here it is, and these are my aligned sequences. Okay, and there they are. So that is a quick overview of how exactly the discovery environment works. You saw originally that you can get your data into the discovery environment or into the data store. The discovery environment can access that, and then you can choose from one of those hundreds of applications there to go ahead and use those applications as you would if you were using it at the command line, but certainly you can follow those menus to see the parameters that you have to put and the inputs. You can follow along with the tutorial or whatever your favorite protocol is to launch and analyze those jobs. Once those jobs are running, you can use the analysis menu to check the status. You can view the history of things you've done previously, and so that helps you be reproducible because you can actually see the settings that you used, and you can see the files that you used, and everything is there and can be exported into a simple text format. Okay, so we have time now for one last demo, and let me take you through that with some slides, and we'll talk about how you can use cloud computing in your research. So let's go ahead and go back to that. Okay, so CyVerse Atmosphere. So as mentioned before, Atmosphere is a cloud computing platform where you have access to hundreds of virtual machine images. You can fully customize your software setup, and it's integrated with our computing and data resources. Now, if you're not familiar with cloud computing, let me give you a couple of pieces of vocabulary or jargon. The first one is something called an image. And to explain that, I'm going to use a little bit of an analogy or a little bit of an illustration here. Imagine that you bought a new computer and you want to take all of your files and folders from the old computer and put them onto the new computer. Well, what you'd probably do is you'd find an external hard drive and you would copy everything from the original system onto the new hard drive. However, there is a file that you could make, or a type of backup that you could make, called an image. And an image file is actually not individual files and folders, but a complete mirror or a complete clone of everything on your original system. The operating system, all of the settings, all of those things that were installed. So if you take documents off of a hard drive, they're still documents. But if you take an image file, you could put that onto a new computer, and that new computer would have all of the software installed that you had in your old computer, all the files, all the data, all the parameters. So an image file is quite comprehensive. It's the operating system plus any other data that might be on that original system. So that's the concept image. The next one is something called instance. So in the CyVerse cloud, we have multiple physical resources. We have hard disks, we have CPU, we have memory. And when you come to us to use the cloud, you're asking us for an allocation of a certain amount of that for a limited amount of time. So what happens is that we give you that allocation, and you also, since you're actually building a virtual computer, you need an operating system, so you'll also take an image, you'll pick from a list, and when you put the two together, that's what we call a virtual machine or Atmosphere instance. And it would be available to you at an IP address. You would log into that IP address, and then you would have access to that computer. So I'll demonstrate those in just a moment. When you are using Atmosphere, you can choose an existing image, so an existing software stack, or you can customize, and then you can image your own. You can get up to 16-core, 128 gig machines. You can access them via the shell, or in some cases, if they have a desktop, using VNC. And you can also share your images either with selected users, or you can make them public. There are a lot of compelling use cases for working with Atmosphere, including running the software and analyzing the data that are monopolizing your laptop. You can use these desktop-enabled images to run visually oriented programs, so you couldn't run a program with a graphical interface in the Discovery environment, but you could use that software in Atmosphere. You also have administrative access or sudo access, so you can install things without waiting for someone else to give you permission. It also, because you have a virtual machine image, you can create a uniform setup. I love walking to a classroom when everyone's on a VM because, I mean, all 30 students have exactly the same software. I don't have to worry about somebody didn't install something or someone has different versions. And if you do develop your own software, it's a great way to make that available to the larger user community. So I'm going to give you a short demo, which is launching and connecting to an Atmosphere instance. Again, all of this is in the Learning Center. I'm going to go back to the CyVerse homepage. And from the CyVerse homepage, there is a link to Atmosphere and also a link to launch. Now, Atmosphere, I'll mention, is something that you need to request access to. It's not by default with your CyVerse account. So go back to the CyVerse registration at user.cyverse and you'll be able to request an Atmosphere login. I'm going to go ahead and log in using my existing credentials. I'm already sort of authorized because I've logged in once before. And what I'm taken to is my dashboard. And from here, I can manage everything that's going on in Atmosphere. So I can launch a new instance. I can see what my resources are, my settings. I can see the things that I've used, that I'm using currently in terms of my allocation, and also what I've done in the past. If I go to my projects, I believe I launched an image today. So there is an image that's available for me. To launch an image, you can from anywhere click the launch or the new button, and you'd say, well, sorry, launch an instance. I can click on instance, and then I can look in a catalog. So suppose I wanted to search for a topic like RNA-seq. I could enter that search term, and then perhaps any images which might have already some RNA-seq software installed. After a few seconds of searching, it does take a little bit, unfortunately, sorry, you would be able to find a list of perhaps relevant images, and you wouldn't have to install those things yourself. You would click on it, and then you could decide what resources that you need, and then you could launch. Now, I'll warn you that not all resources, not all instance sizes might be available at every single moment of the day. It can depend upon how much the system is being used. And I'll also warn you that you do have some limits to your allocations. Everyone starts off with a low allocation, but if you want more resources, you just have to ask us and provide a little justification. But essentially, right now, I could click launch, and that would go ahead and launch and build it. Since I already have one available, I'm not going to do that. So once it is launched and you have a green status of active, I can click on that and get some additional information. So I have a variety of ways of connecting to this instance. The first one I'm going to do is connect via the desktop. So if I click on open via web desktop, it'll take a second, but I'll be logged in, and here I am, I'll use default, on this remote machine. I can do anything on this machine as I would do on a normal computer. I can open up a web browser in that. And I could go to, you know, it's taking to me Mozilla, but I could go to CyVerse.org. You get the idea that this is a virtual computer that I can do anything on. I could go ahead and see, let me close this, what tools or software might be installed. In this case, I believe we have RStudio installed, and there may be some R packages. But the point is that I have this virtual machine that may be quite a bit more powerful than my laptop, and I can use this to do anything that I need to do. The other way to access this, of course, is I could go into Atmosphere and open in Web Shell. So if I click on Web Shell from here, the same thing will happen. I'll be able to connect to it. And now, whoops, this one you have to, I can't zoom in as well, but I could go ahead and I am at the desktop of that machine. Of course, I can connect as I would traditionally from my own laptop. Let's go back to the VNC. First, let me copy this IP address, and let's go back to the web desktop. But from my local computer, I could connect and using SSH. So if you're familiar with this, it would be SSH my CyVerse username at that IP address, and go ahead and connect, enter my CyVerse password, and then I'm also SSH'd into that. And I could do anything, you know, I'd normally do. I could create a folder if I could spell, and there's my folder on my remote desktop. So it's really pretty powerful and pretty flexible that you're able to, within a few moments, choose an operating system that already has software installed, that you could, you know, spare yourself the pain of installing those things. Perhaps it's already an entire pipeline or entire workflow. Then within about 10 to 15 minutes, you have that active. It's pre-configured with the amount of memory, disk, processing power that you need, and then you can go ahead and do your work on that. As you're doing your work, you have to be mindful that the Atmosphere instance is not connected directly to your data store, so the instructions will take you through connecting it to the data store so that you can import existing data from CyVerse directly into that virtual machine. And then when it's time for you to finish, you can take the instances or the data off of that virtual machine and redeposit in the CyVerse data store if you so choose. So going back to the interface here, just a couple of other features. So back on the interface, when you're done, you could decide to stop the instance if you're not going to use it for a while, stop or to spend, and that stopping it will help you so that you cannot spend down your allocation. If you've installed some software and you want that to be a permanent change, you can make a new image, in which case the next time you or anyone else you shared that image wanted to use it, they could. When you're finally done, you can click on delete, and delete will permanently delete that image, that instance rather, and so be careful because no one could recover data from that, so you have to do that with caution. I'm not going to use it, so I'll go ahead and click yes to delete, and that will start the process of deleting. So taking it back and wrapping this up, that is a pretty powerful set of tools to connect and to use Atmosphere because it's a virtual machine that's really fully customizable. So in terms of where to go from here, we advise you to go ahead and check out the Learning Center, as well as upcoming events, workshops, and webinars. So that is all back on the CyVerse homepage. And pull that up and clean this up a little bit. But essentially, that is the next step for you to take a look at the learning materials, including the CyVerse user forum, and just really take a look and see what are the things of interest that you want to get started using. We really are here to help you. We also do workshops. We can come to your institution. We can do it virtually. We can do it in person. But we are committed towards helping you achieve your research and education goals.